Hello there, Professor Lou. My name is Christopher Roseo, and on my honor, I attest that I will follow the letter and the spirit of all the rules of this exam. So, this is going to be part D, part number 4, video number 4, whatever you want to call it. This is hopefully the 4th video in this playlist, so long as I've compiled everything correctly. Moving on, we got 2 questions here from the study guides we're going to answer. Now, there are plenty of choices, obviously. We've done many study guides throughout the year, but I picked 3A from lecture number 14 and 3A from lecture number 19. So our first question is, if you observe light from a distant object that was emitted when cosmic background temperature was Y Kelvin, what is the redshift Z of that light? So our Y in this case, at least for me, for my final and all the math I did there, is 58.2421053. It's a big decimal, I know, but just in case I didn't want to start rounding anything, in case I messed up the answer. So we move on here. This is our equation. Tz is equal to T0 times 1 plus Z. So we plug in everything to the equation and we get this here. Tz is equal to 2.7 Kelvin times 1 plus 58.2421053. Moving on, we're going to add these two together. I'm going to bring that down here. I'm going to multiply it by 2.7 Kelvin. We're going to get this answer down here. Tz is equal to 159.95 Kelvin. And that's going to be our answer here for the first part. Next up, we get the 3A from lecture 19. Now you'll see I wrote the question on the bottom just because I got a little bit carried away and just kind of did all the math first, so just my bad on that one, but the question's here nonetheless. We got a star has W times the luminosity of the sun. How many joules per second does it produce? So I wrote down here this little note: for every 1,000 kilograms of hydrogen, 993 kilograms will become helium number 4. Now that still leaves us 7 of the kilograms of hydrogen. That's going to factor into this one. It's going to give us our 0.7 here, and our equation. This E equals 0.7 times mc squared. Going to plug in the values here. Now my W in this case was this 11,066. So multiply that 0.7, multiply the 11,066, and multiply the c squared, and that's the value for that. So after you multiply all that together, we get our answer, which is 6.97 times 10 to the 20th joules. And so that is going to do it for part number 4, and I will see you in the final part. Bye.